All right, here we go. Moving along, section 8.3. Now we're going to take a look at what happens if that graph doesn't just stay on the y-axis, right? Right now it's been right in the middle of the graph and it's either been shifting up or down, all right? So now what happens when it starts going laterally as well as up or down, all right? So here we go. The equation, just like that standard form, so now we're going to incorporate that bx that's there. So we've either had y equals ax squared or just y equals ax squared plus c. Now we're throwing the b in there, all right? So that brings a different dynamic to the table, but our process is going to stay the same, all right? So here we go. When we see b, that's going to be telling us we need to find that axis of symmetry. So remember that imaginary line going down the middle of the graph, the parabola, axis of symmetry. We're going to abbreviate it as AOS as we go forward, all right? So that we don't have to keep writing axis of symmetry. Not to be confused with a POS. Special shout out. What up? What up, Reggie? You want to say hi to everyone? Want to help? All right. No? Okay. All right, here we go. So the axis of symmetry, that AOS, all right? We're going to find that with this formula. Negative b over 2a. All right, we're getting a and b from the coefficients in the original equation. All right, we're going to replace them with a and b. All right, now our steps here. First, we got to make sure that the equation is in standard form, in that y equals ax squared plus bx plus c. Can't be out of order. It's got to be in order. And then all we're doing is plugging in a and b, and we're going to simplify. So here we go. If we want to find the axis of symmetry, all right, of that equation, first, it's in the correct form. Ax squared plus bx plus c. We're all good. So first thing we want to do, all right, let's find out what a, b, and c are. So a is that number in front of the x squared. B is the number in front of the x. C is the number without the variable. So axis of symmetry, we're going to need negative b over 2a. Replacing a with 2. B with 4. This is important. The negative is there, and you got to use parentheses. B gets replaced with the 4. A gets replaced with the 2. Now we're simplifying. This is why it's important. Up top, it's a negative 4. Down below, positive 4. When we reduce it, it's negative 1. So our axis of symmetry is x equals negative 1. All right? Remember, x equals, right, is a vertical line. So if we're looking at a parabola, we're looking at the line going right down the middle, vertical line, right? Remember, we talked about the axe, swinging the axe, hence why it's x equals negative 1. All right? Now, this here goes right down the middle of the graph. We're going to need that because as our graph starts moving, all right, remember we talked about the focal point of our graph is the vertex. Well, this vertical line goes right down the middle. It happens to pass through the vertex, which is going to help us when we go to graph. So now, if, for example, in our example we just did, maybe they asked us to graph this function, right? We no longer can just plug in negative 1, 0, and 1 because it's moved. It's not in the middle anymore. So now we have to use this axis of symmetry. So here we go. When we're asked to graph it, first and foremost, we're going to find the axis of symmetry. That's going to allow us to find the vertex. Now bear with me, all right? Because here we go. This might throw you off a little bit, but I don't want to fool you. I don't want you to get tripped up. We're still going to need an x and y chart. But the axis of symmetry is going to be our focal point in the middle. So right now it's been negative 1, 0, and 1 because it's been in the middle of the graph. in the middle of the coordinate plane. It has not shifted. All right? Here, because it's shifting, the axis of symmetry is going to be our middle number. And then we're going to pick a point equidistant from both sides, which is really what we've been doing, because we've been having 0, -1, and 1. All right, so equidistant, you're just adding 1, subtracting 1, make our life easy. And then we all know how to fill in this X and Y chart, and we'll graph it. This coordinate that's been in the middle of the X and Y chart is our coordinate for the vertex. All right, it's been our coordinate for the vertex. So here we go. When we find the vertex, we're using the axis of symmetry, and then what we're really doing is plugging in the axis of symmetry. So for us, the X value of the vertex is the axis of symmetry, right? Kind of makes sense. It goes right, the axis of symmetry goes right down the middle of the graph. So we know that'll be where the X value is. When we plug in the axis of symmetry, well, now we'll get the Y value. So the axis of symmetry is the X value for the vertex. When we plug it in, that's the Y value. Shall we? Here we go. So let's say we got this here. All right. If we go to graph it, here we go. I have a B in there now. We got to find the axis of symmetry. So when you see that in there, when you see this in there, that trigger needs to go off. I need the axis of symmetry when we graph. So what's A, B, and C? Right? A is 3. B is -6. C is 1. We're going to plug it into the axis of symmetry. It's negative B. B is -6. That's why this is important here. Over 2A. A is 3. Let's simplify it. Up top becomes the +6. Down low becomes 6. And when we reduce it, it's 1. So our axis of symmetry is 1. All right. Now, let's go graph it. Our focal point in our X and Y chart is 1. All right. That's going to be right in the middle, 1, because it's the axis of symmetry. Then we're going to pick a point on both sides. -1, add 1. Whatever we get for the axis of symmetry are 2 other coordinates. Just take 1 away, add 1. So here, 1 - 1 gives us the 0. 1 + 1 gives us the 2. And then we're just plugging all of those in to that original equation, just like we did earlier. All right? Now keep in mind, we had said this middle number, this middle coordinate is always going to be our vertex. So later down the road, maybe the directions just ask for the axis of symmetry. We only need this part. Maybe the directions ask for the axis of symmetry and the vertex. We only need this and then this middle coordinate. That's it. If it says to graph it, now we got to put this on a coordinate plane. So here we go. Our graph, that 3x squared minus 6x plus 1. Fourth favorite place, baby. Here we go. We pop that up. Let me zoom in here for y'all. All right. And lo and behold, we got our graph. Our vertex of 1, -2. And our coordinates of, our coordinate of 0, 1, and 2, 1. Sorry about that. I got a little fugazi there for a second. All right. So again, those coordinates all matching up. Keep in mind what we said. These coordinates should always mirror each other. And lo and behold, they do. Because this graph is symmetrical. All right. Here we go. Give this one a roll. All right. Now, I know you can hit the pause button, right? Rock and roll. But B is there again. We're finding the axis of symmetry first. So when we go to do that, and we get our coordinate plane, our axis of symmetry is going to be -1. When we pick a point on both sides, -2 and 0. Minusing 1, adding 1. When you plug in -2 and 0, you should get -3. So the three coordinates you got, -2, -3, -1, -4, 0, -3. All right? Now, last part of this. Because that vertex continually moves and it's not sitting in the middle anymore when B shows up, all right, when we got that number in place of B, they express the graph in a different form, and it's something called vertex form. So now it's still a quadratic because it's squared. It's just not written in standard form anymore. It's written in vertex form. So what we got here, the numbers in place of H and K, right? Lo and behold, if it's written in vertex form, we can easily find the vertex. All right? The numbers in place of H and K will tell us what the vertex is. All right? So notice that it's X minus H. Okay? So in reality, and you'll see as we go through our examples, the number in place of H is going to be the X value of the vertex. The number in place of K is going to be the Y value. All right, now keep this in mind. It's X minus H, but H is the X value. So if our example reads X minus 2, the X value of the vertex is really 2, not -2. All right, we're thinking opposite in there. Okay? And I'll show you a quick example here as we rock and roll. So in our graph here, right, normally what we're used to looking at is the x squared. So with x squared, all right, we know our graph's right in the middle. Vertex is right in the middle. So now, for example, if we plug in and use the equation x minus 1 squared plus 1, minus 1 squared, all right, we're thinking opposite in here. When we graph it, you notice our graph minus 1 squared plus 1. The minus 1 really means that it shifted to the right one. And it's because of that minus in the actual equation, right? And then the plus 1 on the outside means that it shifted up 1. So the big thing you have to remember is you're thinking opposite inside of that parenthesis. Thinking opposite inside of that parenthesis. Okay? If this was a plus 1 in here, notice what happened now. It shifted to the left one and up 1. So the number inside of that parenthesis is going to tell us which way it shifted horizontally, thinking opposite, and the number outside is telling us which way it shifted vertically. All right, and that is the vertex. All right, that number is the vertex in place of H and K. So hence vertex form. So here we go. Our example. When we're graphing, we always find the vertex first. We've established that. Axis of symmetry, vertex first. Find the vertex first. Because it's plus 2 in here, the x value of the vertex is really like a -2. Plus 3 outside is our y value. So this is our vertex. Just like we've been doing. Pick a point on both sides. -1, add 1. So my two numbers, when I -1 is -3, when I add 1 is -2. I'm sorry, -1. When we plug them into the equation, we should get a y value of 1. They match. Right? Remember, we're plugging those in for x. All right? Now, when we graph it, I'm going to take this guy away for a second. This is what we should get. All right? Now, putting the whole thing together from the other day makes perfect sense here. This is what we're comparing it to. The vertex, because of the +2, actually shifted left 2. Because of the +3, it shifted up 3. And it's negative. So it should be opening down. And it's actually got that vertical stretch or a little narrower because of the 2. Holy smokes, Coach Dell. That was what we did the other day. Beasts. Savages. All right, here we go. This would be yours. Again, I know you can hit pause. Give it a rock and roll. It's vertex form, so you're first finding the vertex. We always find the vertex, no matter what. It's easy to find here. We don't need that axis of symmetry formula. So when we go to graph it, all right, your vertex should be, there we go. Vertex should be at 1, 6. Remember, it's -1, but it's really like opposite in there. So right 1, up 6. When you pick a point on both sides of 1, 0 and 2, all right, and you plug them in, you should get 9s for them. So your coordinates, 1, 6, 0, 9, 2, 9. All right? Keep grinding, everybody. Keep working hard. If you got any questions, you know how to get in touch with me. All right? See ya.